So in this lesson, you will be introduced to finding the area of polygons with the focus on triangles. I'm going to show you 6 examples. They're going to be different types of examples. Examples 1 and 2 are just going to be pretty basic. Example 3, we're going to actually use trig to find either our base or our height. 4, 5, and 6, it will be on a grid. Number 4 will be just finding the basic area, the basic heights and base, counting the spaces. 5 and 6 are going to be a little more challenging. We're going to be using a distance formula as well as finding the area of triangles around a particular triangle to find what we want to find. So stay tuned and watch the entire video so you can see all 6 examples. So let's look at finding the area of a triangle review. So notice or remember that the area of a triangle is 1/2 the base times the height. And so you can identify the base because it is always perpendicular to the height. So remember, a perpendicular line makes a right angle with what it intersects. And so my height would be here, and my base is perpendicular to that height. So let's start out with this basic example here. We want to find the area of this triangle. So first we want to identify the base. The base is going to be the 4.5. So I highlighted that in blue. And the height would be the 6 yards because it is perpendicular to the base. And so then we just plug it in. 1/2 base, which is 4.5, times the height, which is 6. Multiplying that straight across, we get 13.5 square yards for the area of this triangle. So let's take a look at these 2 examples here. We want to find the area of each triangle here. So of course the formula is area equals 1/2 base times height. And so for example 2 here, we have our height of 3 because that's the altitude, and our base would be 2. All right, because the base here is perpendicular to the height, because we know that because we have this dotted line here extending the base to show that it is perpendicular to the height. So my base is 2, my height is 3, and I'm just going to plug it in here. Area equals 1/2, base is 2, height is 3. 1/2 times 2 is 1, and 1 times 3 is just 3. So the area of this triangle here is 3 feet squared. All right. So let's take a look at this second one here. A little more complicated. We're given a base because this is telling us that this is an equilateral triangle. All right. So we're only given one side here. So first we want to find the angle measures. Since this is an equilateral triangle, each angle is 60 degrees and B is equal to 10. Remember, B is base. So each side would be 10 because this is an equilateral triangle. So all angles and sides are equal. And each angle would be 60. So this angle here would be 60. So I could use this to find the height. Now remember, if you have an angle and a height or a side length of a right triangle, we could use trig. And so we have a right triangle right here because we have this perpendicular or this right angle here. So if I'm looking at half of this triangle here, I cut it up into 2 triangles, and I'm just going to look at this one here, right? I could find my height by using trig. So in reference to that 60-degree angle, I have the opposite side, opposite that 60-degree angle, and I have the hypotenuse of that triangle because it is opposite the right angle. So I have opposite and hypotenuse. So what trig function is opposite and a hypotenuse? So remember, SOHCAHTOA. No, it sounds weird, but it works to help us remember our trig functions. And so opposite and hypotenuse, that is sine. And so if I take the sine of this 60-degree angle, is equal to opposite, which is my height. I don't know that, so I'm just going to call it h. Or hypotenuse, which is 10. Now I have to solve for my height. So I need to multiply both sides by 10. My 10 cancels out, so I'm left with 10 times the sine of 60. And I'm just doing this to find the height. So 10 times the sine of 60 is about 8, or approximately 8.66 centimeters. All right, so my height is 8.66 centimeters. Running out of space here. So I have my height and my base. I can plug it in. Area equals 1/2. Base is 10 because remember all sides are the same because it's an equilateral triangle. And my base and height are perpendicular to one another. And I just found that my height was 8.66 using trig. Multiplying that straight through, I get 43.3 centimeters squared. Alright, so remember if you're trying to find the side of a triangle, if you have an angle in one side, you can always use trig to find that other side. Alright, so now we have an example here of finding the area of a triangle on a coordinate grid. So the first thing we want to do is figure out what is the base and the height. And so to find the height, we can draw the altitude from point B so that it is perpendicular to the height. Remember, it's going to make that right angle with the base. And so if I draw a line from B down to the base, that's my height or my altitude. Because if I extend side AC, it's going to be perpendicular. And so my height here is 3. All right. My base, the base is 5 because if extended, AC is perpendicular to the altitude or the height. So remember, the base and height are always perpendicular. So I can just count these spaces here. 1, 2, 3, 4, 5. So my height, again, is 5. Plugging that into our formula. Area equals 1/2. Base is 3. No, base is 5. Height is 3. So 1/2 times 5 times 3 gives me 7.5 units squared for this triangle. Alright, so we have another example here of a triangle on a coordinate grid, and we want to find the base and the height. So how could we do that? Well, if I look at line AB, I can see that that slope is 1, right? Remember slope? Up 1 over 1, up 1 over 1. So the slope of that line is 1. And if I draw a line from C to that is perpendicular to AB, and it will be perpendicular because my slope here is down 1 to the right. So that is -1. So AB and this line here are perpendicular. So that's my base and height. Now I just need to find the length of these two lines here. How would I do that? I'm going to actually use the distance formula. Alright, so that's my distance formula. And if I label A and B, so those are my ordered pairs, I'm going to label A and B x1, y1, and x2, y2. And it doesn't matter. You could label B x1, y1, and A x2, y2. Doesn't matter. You're going to get the same answer. So if I plug this into my distance formula, I'm going to have 4 plus 2, because minus a negative, right, is a positive, plus, and then my y2 and y1, that's going to be 6 minus 0. So that is my distance formula. Simplifying a little more, that's going to be 6 squared. 4 plus 2, 6. And 6 squared again. Save myself some space here. 6 squared is 36. 6 squared is 36. So I have 2 6 squareds. That leaves me with the square root of 72. And I'm going to actually write that in simplest radical form because I want an exact answer for this one actually. So remember, with simplest radical form, you need to find 2 factors of the number that you're given or under the radical, and one of them is a perfect square. So factors of 72 where one is a perfect square is 36 and 2, because 36 is a perfect square, and the square root of 36 is 6, and that 2 stays under the radical. Alright, so the length of side AB is 6 square root of 2. Alright, so now I'm just going to draw a line of demarcation here. I want to find the length of, I'm going to just call this side D. this point here, D. All right, D and C. And so my ordered pairs there would be 3, 3 and 2, 4. 3, 3 and 2, 4. So I'm going to label x1, y1, x2, y2. So plugging that in. X2 is 3, x1 is 2, so 3 minus 2 squared plus y2 would be 3 as well, minus y1, which is 4. Plugging that in, simplifying. 3 minus 2 is 1, 1 squared, and 3 minus 4 is negative 1, so I have negative 1 squared. Simplifying more. 1 squared is 1. Negative 1 squared is still 1. Erase here to give myself a little more space. Alright. And I'm left with the square root of 2. I cannot reduce that anymore. Alright, so I'm actually going to erase this little piece here so I'm not covering up my ordered pair. So AB, or my base, is 6 square root of 2, right? And I'm going to say DC, or my height, is square root of 2. Okay, so now I'm just going to plug it into the formula for area of a triangle. So area equals 1/2 base is 6 square root of 2. Height is square root of 2. And remember to multiply radicals. Since both of these are under the radical, I can actually multiply the square root of 2 times the square root of 2. And that will actually give me the square root of 4, which is a perfect square. Since I'm running out of space, I'm going to write it horizontally here. So the square root of 4 is what? It is 2. So 1/2. So I'm rewriting the 1/2. I'm just rewriting the 6. I'm simplifying. And the square root of 4 is 2. All right. So 1/2 times 6 times 2 is, what is it? 1/2 times 6 is 3, and 3 times 2 is 6. All right, so the area of this triangle is 6 units squared. I fit it in right here, so 6. Again, area equals 6 units squared for this one. All right, so you can actually use this with any triangle, the distance formula, just depending on what you're given. All right, in this case I had to use it twice to find the area of this triangle here. All right, so we finally reached our last example of finding the area of triangles. We have another one on a coordinate grid. I'm going to actually find it a different way because as far as finding the base and the height, BC is, I couldn't draw a line from BC to point A because they're not perpendicular. So a way that I could actually find the area of this triangle is actually to draw a square or a box around this triangle, right? And then find the area of each triangle around it. So if I label this triangle 1, 2, and 3, and then I'm going to actually just subtract the area of each one of those triangles from the area of the box. All right, so since this is a rectangle, all of these angles are going to be, the angles are going to be right angles. And so it's going to be easy for me to find my base and height because they're going to be perpendicular since I have these 4 angles. So now let's find the area of the box first. So the height of this box is 5 and the base is 7 because I'm just counting the spaces. From 2 to 7, that is 5. And from 0 to 7, 1, 2, 3, 4, 5, 6, 7. So my base and height is 7. So the area of that box, 1/2 base times height, is 35. Well, not 1/2 base times height because I'm not finding the area of a triangle. It's just a box. So just 5 times 7. All right. So I found the area of that rectangle. Now I'm going to find the area of these 3 triangles here. So triangle 1, my base is 3, height is 1. So I'm going to start at the top to give myself some room. Area equals 1/2. 3 times 1, that is 1.5. All right. So area of triangle 1 is 1.5. All right. So now let's find the area of triangle 2. Area of triangle 2 is base is 4. My height is 5, because I'm just counting the boxes. 1, 2, 3, 4. Height is 1, 2, 3, 4, 5. Height is 5. So area equals 1/2. Base is 4. Height is 5. So that is going to give me 10. So 1/2 times 4 is 2. 2 times 5 is 10. So the area of triangle 2 is 10. All right. Finding this third triangle here. So that base is going to be 7. I've already counted it. All right. And triangle 3 base is 7. Height is 1, 2, 3, 4. My height for this triangle is 4. All right. So area equals 1/2. Base is 7. Height is 4. That is going to give me 14. And so I found the area for each one of these right triangles here. So I can take the area of the box, right? And then just subtract 1.5, 10, and 14. Subtract the area of the triangles, and that will leave me with the area of this triangle here. All right. So 35 minus 1.5, which is the area of triangle 1, minus 10, which is the area of triangle 2, minus 14, which is the area of triangle 3. I'm left with 9.5 units for the area of this triangle here. Alright, so we reached the end of our lesson. I want to thank you for learning with me. Some related videos are perimeter of polygons using coordinates, also area of regular polygons. And so those are some more videos relating to this topic. If you haven't already, please like, comment, share, and subscribe. And again, I want to thank you for learning with me.